Hey guys, today we're going to be talking about grabbing absolute value equations. That's what it is, absolute value equations. Now, this is our first time ever talking about absolute value equations, okay? But, as we're looking at this, the graph looks kind of weird, and that's what we're going to talk about first. So the graph of an absolute value equation looks like a V, and we're going to talk about why it looks that way. So to do that, you have to understand that an absolute value is made up of like two linear equations put together. And we have to remember what an absolute value does. So an absolute value equation, if we have one here, f of x equals the absolute value of x. Okay? F of x equals the absolute value of x. So whenever we plug in a number for x, it's going to change to positive. So look at this. If I have a normal x here, if I plugged in -2 for x, it'd still be -2. -1 would still be -1. And that's what this line right here represents. Okay? That's a normal linear graph. Now, if I changed it instead to a negative, okay? If I change it to a negative, everything switches. Whenever we plug in a -2, it changes to +2, and so on. And that's what makes a negative graph like this. Now, here's the key. Whenever we have an absolute value, half of it switches, half of it stays normal. So it looks like this, okay? If you plugged in -2 for x up here, the absolute value of -2 is +2. Plug in -1, the absolute value is +1. Plug in 0, the absolute value is 0. Plug in 1, the absolute value is 1. And plug in 2, the absolute value is 2. Notice how everything's positive. So what this does, if I were to put these points on my graph, I'd have a point at 0, 0, 1, 1, 2, 2, -1, 1, and -2, 2. And so you can see how my graph is both of those put together. So the graph of an absolute value is literally just a V, okay? It's a V. And all we're going to be doing today is talk about how we can move that V around. So let's talk about the different ways that we can move that V around. And it all comes back to this equation right here. Y'all see this? Y equals A times x minus h plus k. So you have that number that's hiding out inside the absolute value with your x. You have that k on the outside, you have the a on the outside. So let's talk about the different pieces here. So first off, your h value, okay? Your h value is on the inside, and your h value, so this is our h value controls our left and right. But I need to tell you something important about that h value. It is a liar, okay? So your h value here is going to be a liar. We can write that out here. What do I mean by that? I mean, do you see how it's a minus in here? So whenever we're trying to interpret it, it's kind of going to be backwards to the way we think. For instance, if it is -4, that actually means we're going to go 4 to the right. That's kind of backwards, because I would think -4 would go to the left 4. But no, it's a liar, okay? So inside the absolute value, it's lying to us. Same thing with this +3. +3 is going to take us 3 units to the left. So everything's just a little bit backwards for h. Thankfully, the same isn't true for k. K tells us the truth. So here's our k value, and k controls our up or down shift. So if my k is 2, then we're going to go 2 units up. And if my k is -5, we're going to go 5 units down. So hopefully you can see that relationship. So whenever we're looking at my equation altogether, we're going to be looking at my h, we're going to be looking at my k. All right? Also, your vertex is whatever h and k is. So your vertex is the point at which our graph forms the V. So the middle of the V, that is our vertex. Okay? All right, so anyways, now let's talk about reflections. So reflection is anytime you have a negative in front, we have a vertical reflection. In other words, if you have a -a, you're going to have a reflection. So what does a reflection do? So our graph normally opens up. If we have a reflection, my graph is instead going to flip and open down. That's the only difference there. Okay? All right, we'll talk about stretch and compress tomorrow. Don't worry about that right now. It's not valid for this lesson. Okay, let's turn the page and let's take a look at these 6 different graphs. Okay, so we're going to take a look at these 6 different graphs. In fact, I'm going to zoom out just a little bit so we can see all 6 at once. Okay? All right, so let's start here with our parent function. This is our parent function, f of x, absolute value of x. It's a v that's right in the middle and just goes up perfectly to both of the corners, and my vertex is right in the middle. Okay, so let's talk about what happens if I add 3 on the outside. Remember, that's our k value. And so if my k is 3, we're going to go 3 up. Okay, so you can see that here. We go up 1, 2, 3. I could put a point, but then my graph is still just going to be a v that goes out both of those directions. All right, so for our function form, this is going to look kind of weird. We have a g of x, and for function form, all you do is you write the change in the original. So my original, all we did was we took our original f of x, and we added 3. Okay, that's it. All right, so now for my equation here, h of x equals absolute value of x minus 3. Okay, well this is going to be the same, except that's my k, and for this one, I'm just going to go down 3. So down 1, 2, 3, put a point, draw it out that way, and draw it out that way. Okay, so do you see here, if it's plus 3 on the outside, we just take my graph and we shift it up 3. If it's minus 3, we just take my graph and shift it down 3. Okay, but now let's take a look at some of these h's. Look at these 2 h's right here. Oh, actually, real quick, function form, we can go h of x is equal to f of x minus 3. All we did was put a minus 3 on the outside of my original. Okay, so now let's talk about our next one. This one, do you see how your number is on the inside? So that negative 2, my h is going to be positive 2. Because your h is the opposite of what it is inside the absolute value. Okay? So if my h is positive 2, and we have a negative 2 on the inside, h controls your left and right. Remember that? So we're going to go to the right 2. It's the opposite of what it is inside the absolute value. So I'm going to go to the right 2, and I can put a point. And we can draw that on there, okay, just like that. So you can see our v just got shifted to the right. Otherwise, if it's a positive 2, that means my h is actually negative 2, and we're going to go 2 to the left and put a point. Okay? And then we can draw that on there. All right? Then, last one. If you ever see a negative in front, that means that we're going to have a reflection. Okay? And with my reflection, that just means instead of opening up, it's going to have that same vertex. We don't shift it around, and it's just going to open down. Let me scroll down and get some more room here. Bam, just like that. Okay? So that's a reflection. Okay, so let's write our function forms for these. My function form for this one is j of x equals f of, and then you're going to write your minus 2 on the inside of the parentheses this time. Same for this one. I'm going to go k of x equals f of x plus 2 on the inside of the parentheses. And in this one, we're going to go m of x equals negative f of x. Okay? Okay. Let's go down here and let's take a look at number 1. So number 1, what we're going to do is we're going to write our equation for the graph that's given to us. Okay? So we're going to write our equation for the graph that's given to us. So you can see your original function notation here, and then what happened to my new graph? Here's my new graph. Okay? There's my new graph. What happened to get it over there? So what transformations happened? Well, we can see My first transformation is I went to the left 2 and I went down 3. Okay? So that's my first transformation. I shifted left 2 and shifted down 3. Okay. And so what's my vertex? My vertex is here at -2, -3. Okay, so that's your vertex. Remember your vertex is your is h and your k. So my h is -2 and my k is -3. And you can see that to the left 2 and down 3. So, but you might be thinking to yourself, but Mr. Martin, shouldn't that be positive 2 because h is a liar, h is backwards. No, h is only a liar when it's inside the equation, okay? So whenever we write out the equation, that'll be the inside. All right, now let's look at the opening direction here. Opening direction is up. So is A going to be positive or negative? Do I need a negative in front? No, it's just going to be +1, okay? That's my A. My A is just going to open up. There's no reflection. So whenever I write out my equation, I'm going to write it like this. I'm going to go y equals, my A is just 1, so we don't have to put it, absolute value of x minus h. So if we're going to minus a -2, we're actually going to add 2. Okay, remember, h is backwards when it's inside the absolute value. Okay, so that's why it's a +2 on the inside, and then we'll have a -3 on the outside. Last bit, domain and range. Okay, so listen, for all of your problems today, your domain is going to be -infinity to +infinity, or x is equal to all real numbers. However, what about your range? Your range is your up and down. So for my domain is, it goes forever to the left, it goes forever to the right. That doesn't change. But my range is different, okay? So for my range, we're instead going to have to think about, okay, how far up does it go? How far down does it go? So for this one, it's going to go all the way up, but it's going to stop here at -3. It's going to go all the way up, it's going to stop here at -3. So what does that mean? That means that my y is greater than or equal to -3, or we could write it like this, brackets, -3 to infinity. So that's really all there is to it. Let's graph one from scratch now, okay? Let's graph one from the very beginning. So here we have an equation, and we need to graph it. So here's the deal, okay? We can see from this that my h is 5, and it's +5 because it's a liar when it's on the inside of the absolute value. And my k is -2. So if my h is 5 and my k is -2, that's going to tell me what transformations I have. So first off, if my h is 5, that means we're going to go to the right 5. And if my k is -2, that means we're going to go down 2. So let's see what that looks like. If I go to the right, 1, 2, 3, 4, 5, and down 1, 2, and put a point there, we can find my vertex. If my vertex is going to be at 5, -2. Okay? Then we can think about my opening direction. And my opening direction is positive here in front. It's positive. So my opening direction is up. So I can go here and just draw my V on. All I did was I shifted my V over. Okay? That's it. I just shifted it over. I shifted it to the right 5 and down 2. Okay. Now, our domain. Remember, your domain for all of these problems is x equals all real numbers, or -infinity to +infinity. But your range is the one we have to think about. Now, I want to tell you something. Your k, or the y of your vertex, is going to give you the number for the range. And if it's above that number, it's going to be greater than. If it's below that number, it's going to be less than. So it's going to look like this, okay? We're going to go y is greater than or equal to -2, or brackets -2 to infinity. Okay? Let's take a look at another one. This one, this one has a negative in front. So what is that going to mean? We'll see in a second. So first off, my h is -2, because remember your h is a liar. And then my k is 5. So what transformations are we going to have? Well, we're going to go to the left 2. We're going to go up 5. And since I have a negative in front, we're going to have a vertical reflection. Okay? A vertical reflection. So let's put all these pieces together. First off, left 2, up 5. Left 2, up 1, 2, 3, 4, 5. There's my point. Okay? Then that means my vertex is going to be at -2, 5. Okay? There's my vertex at -2, 5. And then my graph is going to open down because we have a vertical reflection. So instead of my graph opening up, it's going to open down like that instead. Okay? So this does not change the domain at all, but it does change the range. My domain is still going to be x equals all real numbers, -infinity to +infinity. But my range is different. My range is going to be y is less than or equal to, and remember, we're going to look at my number here for my y value. It's going to be less than or equal to 5, and my interval notation is going to be -infinity to 5. Because think about it. My graph goes down for forever, but it stops right there. It doesn't go any further up. Okay? All right. Last one we have to graph ourselves. We've got y equals x plus 7. So notice this. My h is -7, but I do not have a k, so I only have one transformation. And that's going to be to shift left 7. So we're just going to go to the left. 1, 2, 3, 4, 5, 6, 7. And that's going to be my vertex. So my vertex is going to be at -7, 0. We don't have a negative in front, so my opening direction is going to be up, and we can just draw this guy on here. Okay? So there we go. All right, then remember, your domain is just always all real numbers, but your interval notation is going to be -infinity to +infinity. And then our range. Your range is the one you have to look out for, right? My range is attached to the y in my vertex. Look at my graph. It only goes down to 0. So my graph is going to be y is greater than or equal to 0 or 0 to infinity. Okay? All right, last thing, we're going to write some equations just based on what it tells us. Okay? So here, if my graph is shifted up 3, that means that my k is 3. If it shifts right 6, that means my h is 6. And if it's vertically reflected, that means I have a negative in front. Okay? So you have a -a. So if I were to write this out, I would go y equals, and remember, we're following along with this. We're going to plug it in. So I need a negative in front because we have a negative in front of the a. Then we're going to go absolute value of x minus 6. Notice how it's backwards. It was a +6 there. Now it's a -6. And then plus 3 on the end. Okay, next one. Horizontal translation. Those are just some big words that it moved. It moved horizontally. So horizontal is left and right. So if it was a horizontal translation of 5 units to the left, that means that my h is -5. And then a vertical translation, vertical is up and down, 9 units down, that means that my k is -9. So if I wrote out this equation, I would go y equals absolute value of x plus 5 minus 9. Oh, there's the bell for end of school, but not the end for us. Okay, so now translated left 5 and down 9. So left 5 is meaning my h is negative 5 again. And then down 9 units, my k is negative 9 again. So you can see here, guys, this is just the same way as writing that one above. It's just written in a simpler format. So I wanted you to see the difference there between those two. So here we're going to write this one. We're going to go y equals absolute value of x plus 5 minus 9. All right, what if my k is negative 7 and my h is 3? Okay, we can write this one out. Y equals, it doesn't say anything about the a, but if y equals if my y equals, there's no a, so my h is 3, so we're going to go x minus 3, and then my k is negative 7, so we'll go minus 7. All right, the last one here, number 9. So number 9, we instead start with the equation, and we need to write the translations. So if I have a 2 inside here, that must mean that my h is negative 2, which means we're going to translate or shift left 2. And then if my k is 5, we're going to go and up 5. Okay? All right, we're going to stop there, but real quick, I want you to take a moment and summarize, describe what h and k do to the absolute value function. Okay? We're going to say h is your left / right shift, and it's a liar. Okay? K is your up and down shift. And it tells the truth. Okay? All right, hopefully this video has been helpful for you. If you have any questions, as always, let me know. Thanks, guys.